Okay. Again, welcome this morning to Confined Spaces for Construction. This is Tom Wilder. A lot of you are in our webinars about every week. Some of you are new. As normal, our webinar today is scheduled for an hour and a half, but regardless of length, you'll receive 1.5 hours credit, which you can use for obtaining or maintaining EHS certifications such as your mesh certification. Again, I'm Tom Wilder. We'll be talking about confined spaces for construction. If you need more information, of course, you can go to nclabor.com and osha.gov. And for those of you who do not know me, I've been with DOL about 5 years. Prior to that, I worked 28 years in various safety training and quality management positions in the textile, machine assembly, and pharmaceutical industries. Most of those years were in pharmaceutical manufacturing, from which I am now retired. At this point, let's go through logistics. Look around your work area. Try to limit any distractions. If you have an office, you want to close your office door, turn phones off. If you're in a cube, you might want to use headphones and put up a do not disturb note. And if you're new to this webinar tool, I'll be advancing the PowerPoint slides as we go through the class. In the bottom left corner, you'll see an emoji. We will not be using that today due to the size of the class. And in the bottom, you'll see a chat box, and I see a lot of you type good morning, so you're very familiar with the chat box. So you'll be chatting with me. I'll be asking you questions. You'll be asking me questions, and you'll be using that chat box. Again, to get credit today, you must attend at least 80% of the time, and I'll review that after the webinar's finished to make sure you've been on long enough to get credit. And we cannot give credit to anyone who's not registered and logged in. So if you're registered and logged in, you have people sitting around you, they won't get credit because they're not registered. You'll get a certificate probably within the next 3 weeks. They're typically processed once a month. So again, welcome to Confined Spaces for Construction. Now, I noticed from the registration that a lot of you are in general industry. So this is the OSHA standard for construction confined spaces. Now, you'll find that it's very similar to the general industry requirement, but it is a little bit stricter. But if you're in industry and you're performing construction activities involving confined spaces, then you would be covered with this standard as well. So those of you who are familiar with OSHA standards know that before 2015, the construction standard for confined spaces was about 2 paragraphs long, and it was performance-based, and it said all employees required to enter confined or enclosed spaces shall be instructed as to the nature of the hazards involved, precautions to be taken, and the use of protective and emergency equipment. The employer shall comply with specific regulations that apply to work in dangerous or potentially dangerous areas. Well, that was a performance-based regulation, and what was happening is a lot of people in construction weren't doing much of anything with confined spaces, and there were a lot of people getting hurt, killed, and injured in confined spaces. So in late 2015, a new confined space standard came out for construction that is actually stricter than the general industry standard. It's stricter. Has a few requirements, again, that general industry does not have. We'll talk a little bit about both, but again, our focus today is on construction confined space entry. Now, before we get started with the slides, let's go ahead and do a couple of instant polls. And the first thing I want to ask is your experience level. What is your experience level with this topic? So let's go ahead and start this poll. So confined space for construction versus general industry. It's good to know how experienced our class is with this particular topic. And right now we have 9 people, 10 as beginners, 13 as intermediate. We have 1 advanced person online. So as you would expect, there's a little diversity here in as far as what you know about the construction standard. Of course, that's why you're on the webinar. And hopefully you'll learn something you didn't know before today, and we'll see once we get through this webinar. So let's go ahead and stop this poll and close it, and go ahead and ask you one more question that I like. And this one is on professional safety experience. And we want to share the results. Start. Want to know how much safety experience my class has. And we're probably going to see a lot of diversity here. We have new folks, people that are working towards senior level. We have senior level, and then very senior people that have over 10 years experience. So we have a pretty good balance here today of the experience level as far as our students are concerned. And believe me, please add anything you'd like in your comments today. We like to learn from you and from me and from our material. So we appreciate your comments. Okay, so that's our experience level. It's pretty level across the board. And let me go ahead and close that poll. All right, now we're ready for the slides. So if you're in the OSHA standard for construction, you'll see that it's subpart AA in your 1926 construction standard book. And today what we're going to do is we're going to, of course, define confined space. And the definition is the same as general industry. And you want to recognize the difference between a confined space and one that requires a permit. That would be the same as the definition from general industry. How do we determine hazards within confined space? What are the responsibility for the different players in a permit entry? The person that goes in, the entrant, the attendant, and the entry supervisor, and also rescue and emergency services. Okay. Now, we want to protect workers that are involved in construction confined spaces because we know that it can be very dangerous. And if you hear the news, a lot of times when you have a fatality in a confined space, by the time rescue gets there, sometimes you'll have multiple fatalities because people aren't trained and they go into a confined space and are overcome by a dangerous gas or some other hazard. So again, it's a very important topic that could be extremely hazardous. Now, if the space meets the definition and has serious safety or health hazards, it will be a permit space. So the person going into the space has to enter under a confined space entry permit. And that's what you're used to in general industry all along. Now, if you have no potential for atmospheric hazards, it may be reclassified with ventilation. We'll talk about that as well, just like the general industry standard. Now, right now, we're looking at a water tower that's under construction. It's not finished yet. Now, let's pretend that the dome, let's pretend that dome is not on there yet. So there's no dome yet. And all we have is that bowl underneath. Now, if you're performing construction and you have people inside the bowl down at the bottom, and they're welding and cutting, would that be a permit required confined space? You can go ahead and let me know what you think. Okay, you got inwardly sloping walls, right? So that would be a permit required confined space, even though it's not enclosed yet. And also, someone mentioned inwardly sloping walls. If there's a way people can become entrapped in pipes or anything, and they're in that bottom or anywhere in there, that would be another hazard. So when you're in construction, it doesn't necessarily have to be totally enclosed to be a permit required confined space. Okay. Now, North Carolina adopted the new standard with an effective date of October 2nd, 2015. And then there was a delay on enforcement, but we're well beyond those dates, so we're not going to worry about those dates right now. And it does not apply to excavations. So if you're doing excavation and trenching, generally speaking, it doesn't apply, except with an exception, and there are two other exceptions listed there, as you can read under 1926 subpart S and subpart Y for diving. Now, if you got an excavation or trench and you got a pipe in there, and a worker enters the pipe, now you have a confined space entry. So if you're in a trench, you're under the trenching standard. If you're in a pipe within the trench, you're under the trenching standard and the construction confined space standard. Okay, and here's some other things that apply. Work done in a ground space that does not involve altering the structure is covered by AA, like what we're talking about today. Now, okay, right now we're looking at a drawing. Now, first of all, is that a trench? Is this a trench? I see a trench box. Okay. Okay, right. Can't be wider than 15 feet, but what do we not see at the right? Right, Joel. What do we not see at the right? Ground. That's right. There's no wall on the right. So let's go ahead and make this into a trench. So we're going to pretend this is yellow dirt. Should be brown dirt. This is yellow dirt today with my highlighter. Now we got a trench. We got dirt on this side and dirt on the right side. Now what other issues do we have with this trench? We got it on the right and we got it on the left. What's the problem on the left side now? Okay, Joel, you're right, void. So we're going to have to fill this in. So we're going to fill this in with dirt. We don't want that trench box moving around. We're going to fill this in with dirt. And Keith has just noticed something also wrong here. The height of the box is below ground level. That's another problem. So this trench box needs to be even with the ground. It needs to be even up here. Now, a lot of people think that the trench box needs to extend higher, but it really doesn't. There's a letter of interpretation on that from Federal OSHA. So that trench box is going to have to be level, at least level with the ground. Now, if you're going in and out of this trench, what else do you need? Okay, Charles, that's a good comment. You might need a wider box. You want a ladder. It's hard to draw a ladder, but you want to draw a ladder. And, okay. And it needs to be within the trench box. Now, inside that box, we have a giant pipe. When I go inside that pipe, what have I just done? If I go in the pipe, I have just performed a what? Confined space entry. And the way I look at it, you're going to be entering a permit required confined space because you're underground. You've got not only hazards, but you have potential hazards. So when you go underground, even if you don't have any hazards right away, you can have potential hazards. So I'm going to go ahead and erase all that, and let's go to the next slide. Now, this definition is in the construction standard, and it is the same as the definition in general industry. So it's a space that I can get into, my body can get inside. It has limited or restricted means for getting in or out. It has a short door. You might have to use a ladder. It's hard to get in and out. And it's not designed for a person to be in there all the time. That is a simple confined space. Now, do all confined spaces need permits? Do all confined spaces need permits? You're exactly right. A confined space, if there's no hazard or no potential hazard, then you don't need a permit. So a lot of people, when they're looking at a confined space, they're not thinking about potential hazards. If I'm working underground, things can change underground. So let's go ahead. Can you go ahead and give me some typical hazards for working below ground? What are some hazards for working below ground for in confined spaces? Now, for trench of cave-in, bad air, fumes, gas, low oxygen. What kind of water? Great answer. What kind of gases can we have? Communication, that's good. Carbon monoxide, okay. Electrical, mechanical, hydrogen sulfide, carbon monoxide. Methane, okay. Now, we've had some fatalities nationally. For one, hexchrome, that's great, natural gas. We've had some fatalities nationally that involved a gas that's not one you have listed. If you have okay, nitrogen, that's a good answer, not the one I'm looking for, but a great answer. What's a gas that we have not mentioned that you get from decaying organic matter? Decaying organic matter. Okay, methane's a good answer. Okay, James, you got it. Carbon dioxide. So when you're doing atmospheric testing of a confined space, typically you're not going to get CO2 on a 4-gas meter, but you'll get low oxygen readings. So when you get a low reading on something or you get an alarm, sometimes it can be something else like CO2. So don't ever forget about CO2 because that can also accumulate underground for sure. Okay. Now, entry. If we've defined a confined space, an entry means if you put any part of your body in that space, let's just say it's a manhole. If you break the plane, like Keith says, that's an entry. Now, let's just say you have a manhole. Let's say you're installing sewer pipe and you got a manhole. It's construction. You got a worker that goes up, the manhole cover is gone. A worker sticks their head in the manhole. That's an entry. What can happen if they stick their head in there? If they stick their head in there, what can happen? Right, they can inhale fumes or gases, fall in and die. Asphyxiation, like your nitrogen example, or carbon monoxide, it can be asphyxiation. So, like I said, an entry is any part of your body going in. Okay? And that slide pretty much says it. Now, these slides here, you'll notice they're very wordy, so I'm not going to read you every word on the slide. I know you can read the slide quicker than I can read it to you. So we just want to make sure we're covering the key points on each slide. Now, control means we're taking an action to reduce a hazard or eliminate a hazard. A controlling contractor is an employer that has the overall responsibility for construction at a work site. Who typically at a construction site, let's just say somebody's building a building, who's typically the controlling contractor? Who is the, okay. Okay, there we go, GC, general contractor, that's what I'm looking for. On a construction site, you'll have a general contractor and your subcontractors. So the general contractor assumes responsibility for being the controlling contractor. If the controlling contractor is not around, who can assume the role of controlling contractor? Who can assume that role? Okay, it can come down to the foreman. And what I'm looking for, Marilyn, okay, manager. Now, competent person we're going to talk about in a minute, but the host employer, the owner of the project owner, if the GC is not there, would immediately assume controlling contractor role. Okay. Now, you got the host employer. That's the person who owns or manages the property. Monitoring means we're going to identify and evaluate hazards. Now, early warning system. This is something that's different about the construction standard for confined space. Let's just say if you're constructing a sewer system and you have people in that pipe, they're working, it's underground, it's underground level. In this confined space standard for construction, you have to have a system to alert those entrants that engulfment hazard may be developing. So let's just say you have people in sewer pipe. Obviously, it's outside. You're installing pipe. What could cause an engulfment hazard for those workers? What can cause an engulfment hazard for those workers? What can happen? You got a confined space entry going on. You're installing water. Okay, where's that water coming from? Where would the water come from? Okay, right, rain, or it can come from the main line, or from the sewer, line break. Anyway, leak upstream, those are all great answers. So if you're doing a confined space entry in a situation where you can have engulfment in your project plan, you have to have an early warning system designed to get those people out before the hazard gets there. Rainstorm develops, something breaks, we got to get those folks out of there. Okay, physical hazards could be explosives or mechanical, electric, hydraulic, pneumatic, radiation, temperature, engulfment, noise, inwardly converging surfaces where people can become trapped, or chemicals that can cause death or serious physical harm other than inhalation. Those are all physical hazards. So if you have something mechanical in a confined space, or electrical, or hydraulic, or pneumatic, what shall you do before you have a confined space entry? Lockout, tag out, exactly. You're right there with me because you want to eliminate all the hazards before anybody goes in there. Okay, now if you're doing a confined space entry in construction, now this is a little bit different than general industry. In construction, you have to evaluate all the confined spaces on the site and identify those permit spaces. So like say the general contractor, for example, would have a competent person. You've got a building shell built. It's not finished. And there are a number of confined spaces that exist. The regular confined spaces do not need to be marked, but the permit required spaces need to be labeled with signage, or you have to have a way where absolutely everybody would always know what those permit spaces are. And on a busy construction site, without labeling or signage, I don't know that anything else would be possible. So that competent person is going to have to evaluate all those spaces and determine which are permit required spaces. So you got a site, you got a building shell, and then you got subcontractors coming in. That's how they're going to know where the permit required confined spaces are. Okay, and we just said this. All permit spaces must be posted or identified in some way. Okay, now if you don't want anybody to work in these permit spaces, the employer must have a way to keep people out. And I know even in general industry, it's the same thing. If you don't want workers in there, you have to have a way to keep people out. And you need control of that site because you don't want people entering that don't know what they're doing. You don't want people just walking in there that don't understand what's going on. They could end up as a fatality. So that's why on a construction site you have control of the whole site. You have fencing. You don't want it where kids can come in and get into a permit required confined spaces because kids like to do that. And in general industry, like I said, it's the same. You want to keep people out of your permit spaces if you don't expect them to go in there ever. Now, like I said, pipes. A pipe, for example, kids like to crawl through pipes. We don't want kids going through pipes. So, and of course, other people might too. Now, the kids are probably not going to have access to these confined spaces because we're talking about construction. And hopefully there's some good control on the site. Okay, now, you may use alternate procedures for entering a permit space when the only hazard is the atmosphere and you've eliminated the atmospheric hazard. You've reclassified that to a non-permit space by use of ventilation. So just like general industry can do that too, if it's only atmosphere and there are no other hazards or potential hazards, then you can reclassify that as a non-hazards or potential hazards. Then you can reclassify that as a non-permit space. Now, you have to know that the ventilation is sufficient. You need to develop data, monitoring data, and document. So this is something also new to construction. If you have a permit required confined space and air is the only hazard, if through ventilation, you can turn that into a non-permit space, that is fine. Now, one thing, although you must remember, is how would a contractor know if the atmosphere is bad or good? How would you know? Right, air monitoring. So typically they might have a 4-gas meter. So if you're reclassifying a space and you know that atmosphere was a hazard, then you better use the combustible gas, or your actually 4-gas meter, I should say, 4-gas air monitor, and do some monitoring, document what you're getting, ventilate, and then document that there's no hazard. And one thing that in construction you'd have to do, if there's any potential atmospheric hazard, you have to do continuous monitoring. General industry says periodic monitoring, but in construction you would be doing continuous monitoring. Okay, so if you got a confined space like this picture, somebody removes a manhole cover, they should be guarded by railing or temporary barrier to keep somebody from falling in there. Now, what's unusual about this picture there? It looks like you got a permit required confined space going on. There are two right beside each other. What am I not seeing there? There's something missing. Attendant. That's right, Keith and Erica. That's exactly right. So the attendant's there for a couple of reasons. And Judith, you're right, supervision. Now, your attendant would be doing a couple of things. They're going to be monitoring the person that's in there for their safety the whole time. And they're going to keep other unauthorized people away. And they're going to try to keep vehicles away from that space. Now, what would be the issue if a vehicle pulled up adjacent? Keith, you've already got it, carbon monoxide. You're on the ball, Keith. Like I said, if you had a vehicle running there, it could be dumping CO in there and making that space a dangerous confined space for sure. People can't go in until forced air ventilation has eliminated the hazardous atmosphere. Okay. And the air shall be from a clean source. So you're not going to set up a forced air ventilation beside a running vehicle that would be introducing carbon monoxide, for example. So you want clean air. Now, this is very, very important for the people that are performing construction. You've come to a space that's a permit space, and the atmosphere is the only hazard. What you're going to have to do is you're going to have to do some monitoring, air monitoring, and you're going to have to do some documentation and sign it, the certification that that space had hazardous atmosphere, and you've done some testing. These are the results, and you'll do 3-level monitoring and document results, and you will have that on a certificate. You would have that on a document. Otherwise, somebody would come up and say, look, you've got somebody working in there and it's not set up as a permit space. What's going on? Well, you would say the competent person evaluated the space, they ventilated the space, we're doing continuous monitoring, and there's no hazard there. Okay? All right. Okay, if there are changes to a space, again, the competent person needs to reevaluate the space. Now, if you're a contractor and you go to a construction site and there's nobody else there, GC's there, not there, the host employer's not there, and you see a confined space, any confined space, when you look at that space and try to decide whether to go in or not, the person making that decision has inherited the role as competent person because you're making the decision to go in or not. And what you could have is you could go to a building site and all the permit spaces are marked and there's a non-permit required confined space that's changed Somebody's running a generator. You know, the conditions has changed. Carbon monoxide in that space. Uh, if you decide to go in, you had to make a decision as a competent person. Just something to know. And like I said, the competent person is a person that determines that all requirements have been met before there's an entry. Okay, so you've got to have communication and coordination. And on a construction site, you've got to have coordination between all the contractors, communication between all the contractors and the GC. And the host employer needs to know what's going on and what their site is like, where the permit spaces are, typical hazards, and that sort of thing. Okay, so before operations begin, the controlling contractor obtains host information about the site and provides that information to anybody coming into the site to work. Okay, and precautions that people need to make. Like I said, this is just copied straight out of the standard. Now, before you go in, you have to have all the information about the hazards and procedures that people need to follow. Okay. Now, the controlling contractor and the subs must also coordinate if you have people from different companies going in at the same time. There would be a lot of coordination done there. Okay. And after entry operations, they must again debrief each entity that enters the space and just communicate all the information. Like I said, this is pretty redundant here. We've said this already. If there's no controlling contractor present, and the host employer is going to inherit that role. Or if they're not there, you've inherited the role as controlling contractor and competent person. Okay, so when you have these entries, you must have measures to prevent unauthorized entry. How do we keep people out? And we must evaluate hazards and identify and develop controls to eliminate those hazards. Now, in these entry operations, you need to provide equipment at no cost to the working employees. There's your ventilation, your meter, and there's a tripod that's used for rescue. Now, are tripods always good for underground rescue? Tripods. No, that's right, Colleen, Debbie, Jennifer, because if it's not a simple space like they're just going straight down, like James said, if they're going down and going laterally around pipes and all kinds of strange configurations in there, if the attendant is trying to rescue that person, they're not going to be able to winch them out because they're going to get, the entrant is going to get hung up on all that piping or whatever they're entangled with inside. But the rescue needs to be pre-planned. You're sending somebody in there, it's a permit entry. How are we going to rescue them? And we'll talk a little bit more about rescue here in a minute. Okay, you want to test conditions like, say, the atmosphere. And we're going to provide, this is a permit required confined space entry. Now, the company that's sending that person in there, they're going to need a written program for how they perform permit required confined space entries. There's going to have to be a form, and they're going to have roles. You got the entrant, the attendant, and the supervisor. So you're going to have at least one attendant outside who's authorized to watch out for those entrants during the entire operation. Now right here again, we don't see an attendant there. The attendant has to be there monitoring at all times. Now, like general industry, if you have two adjacent spaces that can be monitored by one attendant at the same time, you can do that. I think that's pretty unusual, but the attendant must be able to fulfill all of their roles if they have more than one space without distraction. Now, what is one of the biggest distractions to an attendant during a confined space entry? What is something we would not allow? There we go, Joel. That's right. Phone. If they're using phones, if they're on the phone, their mind is not going to be on what they're supposed to be doing. They're protecting the life of the person that's inside that space. They're looking the whole time. So in your training for confined space entries, whether it's general industry or construction, you don't want the attendant to be on the phone. Now, what is the only time they would use a phone? Emergency, that's right. That's great. So it's not that a phone is bad, but that's the only role for a phone during a confined space entry is emergency use. Now, you're going to designate the different roles of the people. Are they people that go in or the entrance? Or the attendants that watch over the entrance? Are they supervisors? Are they people monitoring the atmosphere? Now, let me go ahead and ask you this, and this is also true for general industry. Can the attendant also be the supervisor? You can buy. That's right, Keith. That's right. So you can have an attendant also fulfilling the role as supervisor. Now, they must be trained in both roles, but you can have a dual role attendant, supervisor, and like Judith said, if it's manageable. Okay. Now, also, you're going to also pre-plan procedures for summoning rescue and emergency services. Now, one of the biggest problems with confined space entry that require permits in industry and construction is a lot of companies, what they'll do is they have a written program and they have a permit, and who do they put on their permit for rescue? Who might they put? Fire department. That's right, Tony. Local EMS. Now, the problem is they did not pre-plan rescue. They did not train on rescue. The response time is not good enough. And the fire department may not be equipped for the type of space you have to do a proper rescue. So there are a lot of things about rescue that you don't want it to be a shortcut. If you're doing an underground confined space entry and there's a chance of a hazardous atmosphere developing, which is very likely, even if you got great atmosphere, because we talked about methane, hydrogen sulfide, carbon dioxide. Things can change in those spaces. If there's a good chance of atmosphere changing in there, with the fire department not being on site, would that always be sufficient? The rescue not being on site? No, that's right. So it's kind of like, it's kind of like medical response anywhere. If your response time is going to be too long and all it's going to be is a recovery operation, then that's just not a good plan. So again, you want to pre-plan your rescue. And you want a system. This is part of your written program. How do you prepare, issue, use, and cancel permits? And how do you terminate them? How do you coordinate activities with other contractors? And what this slide shows is there has to be a lot of communication and coordination between everybody on these slides. On this slide, you got the subcontractors communicating and coordinating with each other, with the controlling contractor, which in many cases would be the GC, and then between the GC and, say, the owner of the project or the site. Continuous communication, because things are changing all the time. All somebody has to do is come in and set up a generator beside or over a confined space to change everything, run a generator. So you want communication. Now, what person is going to cancel or terminate a permit? What person does that? The supervisor, that's right. That's part of the supervisor's role. Now, one thing about the construction confined space standard is that the permit could be suspended for a while, just for a little while. Instead of closing it out, canceling it, and terminating it, let's say you've got an outside confined space entry going on, and you got people in that confined space, you got an attendant, everything's going along great. What could come up to cause a suspension of an entry? Okay, lunch, okay. That's a good example. What else? Bad weather, right, Judith? So you could have everything going along and have a thunderstorm or severe weather approach, and you got to get people out. Well, you get everybody out, you go to a safe place. Somebody pulls up weather radar. They know this storm's going to pass, and it appears that water is not going to be a hazard. If it is, it might have to be pumped out. But there's a good chance you'll be resuming that permit once things pass over and you make sure everything's safe again. Okay? Okay, review entry operations with measures may not protect employees. So you want to make sure everything you do does protect employees. So you want to review everything you're doing and make sure you don't have any deficiencies. And what you're going to do, like general industry, this is construction, you're going to maintain 1 year's worth of canceled permits. In other words, that have been closed and finished. And you're going to look at all of that and try to decide, is there anything we need to do to improve our entry operations? Are there things that we do that can be improved? You're going to be looking at those permits once a year and see and make sure that you're doing the best job you can to keep people safe. Okay, so you're doing an entry. You got to document everything you need to do on the permit, like air monitoring, personal protective equipment. You have a signature to authorize entry from the supervisor, and the duration of the permit within the scope of the job. And this, again, the supervisor is the one that terminates the entry. Cancel permits, that's your supervisor. We've already talked about that. Entry the permits, it talks about what space are you going into, why are you going in there, who's going in there and for how long, and who are authorized to go in there. Because the people that go in there need to be trained as entrants. How are you going to detect an increase in atmospheric hazard, like with continuous monitoring? All the people on the permit by name, the hazards, measures, and controls that you've taken to make the space safe. Test results, phone numbers, whatever you need to summons emergency folks. and communication between entrants and attendants. So you've got somebody in a confined space working, and you've got the attendant outside. Now sometimes the attendant can just look down there. I mean, the person may be 6 or 8 feet directly below the attendant. Voice communication might be good enough. What other forms of communication can you use? Radio, okay. Hand signals, okay. Even things like tapping, Morse code, air horn. Now you want two-way communication. Just make sure there's a way to have two-way communication between your entrant and the attendant, because they may not be within sight or voice communication with each other. You've got to have a way to communicate. Pull cord. John, that's a great answer. Pull cord. So the attendant tugs on the cord, the entrant tugs back. Are you okay? I'm pulling back. I'm okay. Headsets. Number of tugs on the rope. Speaking the same language, right? You need to be able to communicate. Okay. All the equipment must be provided, and anything else the person needs to know needs to be told to the entrant. And any additional permits that need to be performed, such as hot work. Okay, so somebody's cutting or welding inside of a confined space. Um, you want a hot um, you want a hot work permit for that. Now, could you have a dangerous atmosphere from somebody cutting and welding? Yes, Keith, you're right. So ventilation is critical, but anyway, hot work, that's another required permit that you would need to have. Training. Now all your employees need to be trained without cost, and you got to have some way of assuring that they understand what you're talking about. Now, is confined space training, is it always a good idea to have confined space training in a classroom only? No, that's right. So them watching a PowerPoint presentation isn't going to quite get it. You need hands-on, like Janie said. So you want hands-on training. You want to simulate what they're doing. You want them to be familiar with the types of spaces that they have, and like Keith says, train on their role. Are you always going to be an entrant? Or are you going to be an attendant? Or are you going to be a supervisor? Or are you going to be all three? You need to be trained on that particular role. Or are you going to be performing rescue? Are you going to be going into space to rescue? Or are you going to winch somebody out of the space rescue? All that is within training. It has to be trained in the language and vocabulary that everybody understands before people actually do the work, before there's a change in duties, and whenever a change of operations that presents a hazard that's new to them. Okay, and you want to train people. If you've watched a confined space entry operation and they're not following procedure, then that needs to be stopped and people need to be retrained. People must show that they're proficient in what they do. And your training records have the employee's name, who the trainers were, the dates, and pretty much what was covered. And all that documentation must be available for your employees. Now, for the people that go in the space, the entrants, they need to know about all the hazards or potential hazards and what would happen to them if they didn't do anything. Properly use equipment, how to communicate with the attendant. Now I'm going to tell you a quick little story. When I was in the industry, we had a confined space entry operation going on. It was permit required. I didn't have anything to do with this particular entry that day, but we had a maintenance worker working in a manhole. Uh, everybody was in place. Everybody signed the permit. The air monitoring, all that was done. And the person, it was probably a cold day, and that person had a jacket on. He put a spray solvent inside his jacket and took that into the space. So anyway, what happened is we were doing continuous air monitoring, and a person uh, decided to spray solvent to dry some electrical contacts inside the space. Now everything was locked out. There was no electrical energy there. But he sprayed solvent inside the confined space. Now we were doing air monitoring. What do you think happened? Okay, the atmosphere could have been flammable. The atmosphere changed. Actually, like Judith said, we had an alarm, and we had IDLH conditions, like low oxygen, like James. So you have an alarm going off. Now, the person that went in did not tell anybody that they were going to take that solvent in there, that spray solvent in there. And next thing you know, you have an alarm going off. Now, luckily in this case, the entrant was able to get out of the space on his own. But with an alarm situation, the attendant would have had to get into rescue mode otherwise. But you need to have complete communication. You need to know every single thing that's going into that space. Because one thing like that can change things from one extreme to the other, like IDLH. Okay, the attendant's going to be alerted by the entrant when there's some kind of symptom of exposure. The person starts feeling funny or different, or the entrant says something's wrong down here in this space. And of course, they're going to get out as fast as they can. Okay, and the attendants. Now we're going to go to the attendant. Now the attendants outside the space. They need to know about all the hazards. They need to know what it's like for the entrant to be exposed to something that might be down there or might develop. And they need to know, and with a permit, on who's in there and how long they've been in there. And the attendant, let's say you have an alarm and you have an attendant. Of course, this picture, there's no attendant there, but you have an attendant standing there. The attendant has to go into an entry rescue. Through their training, the attendant can't leave their spot until another attendant relieves them for the first attendant to go in to do a rescue. Now, this may involve SCBA, because the attendant can't expose themselves to a hazard. There's procedures and rescue things that have to be performed by the attendant that's going into rescue mode. Okay, the duties. They need to know what safe conditions are like, behavioral effects, prohibited conditions, anything that can happen to hurt the person inside that space. The attendant's going to initially summons rescue. If they're not the rescue person, there's where your phone's coming in. And they want to warn people to stay away from the space during the operation. And anybody that got in there, I don't know how somebody's going to get in there. It says advise unauthorized persons that they must exit immediately if they've entered it. Well, if they're beside the space, I don't know how they got in there. So they want to keep unauthorized people out. The attendants can perform non-entry rescues per the procedure. Like if you have a winch, they can winch the person out. And you don't want them doing anything else that's going to distract them, like talking on their cell phone or you don't want them to have any other duties. Okay, now we're to the supervisor. We've talked about the entrant, the attendant, and now we're to the supervisor role. The supervisor needs to know about all the hazards that are faced or could be faced, signs and symptoms of overexposure, that the permit has been properly filled out, that everything's addressed on the permit, that all the testing was done, terminates the entry or suspends as needed. Okay, let's say the person who's the attendant, let's say they're doing the air sampling. They're in air testing, and they're going to test that air right there in the space before anybody goes in. Now, what's required before you're going to use that testing equipment? What are you going to do? Bump test, right? And Keith says calibrate. Now your equipment is going to have to stay within calibration at all times. Your equipment manufacturer is going to determine how you calibrate this equipment, your calibration frequency, to keep it properly adjusted against standard gases. Now you got a calibrated equipment, but can you use calibrated equipment without doing a bump test? No, that's right. So a bump test is going to assure that that equipment's going to alarm and do what it's supposed to do. Now, I will tell you, years and years ago, now bump tests have gotten pretty specific. But in the old days, before the bump test became sophisticated, how would somebody bump test a meter? Give me some examples of what people used to do to bump test. What did they use to make it alarm? Can you think of anything? Okay, Bird. Exhaust gas. Okay, that's right. You could expose it to exhaust gas. Now, we're not going to, in the old days, I'm sure there were days where people used birds and canaries. That's not what I was looking for, but that's funny. So you could put it up to a tailpipe of a running car. And Colleen says they still do that in coal mines, right? Now, okay, you got that exhaust, and I'm not saying do this. This is not how you're going to bump test. This is not good. What else could you put? You got a hose there that's sniffing the air. You got that tester running. What could I put at the end of that hose that would make it alarm besides a car exhaust pipe? There we go, James. Like I said, you could breathe into it. So block there with finger, okay. So carbon dioxide is going to make it alarm. And I will tell you one other thing. Now, do not use these things. Do not do what we're saying as your bump test. Your equipment manufacturer has a sophisticated bump test against known gases. But in the old days, people used to take things like not Sharpies, but markers, like Marks a Lot. If you ever had a Marks a Lot permanent marker or something like a Marks a Lot brand, if you have one of those permanent markers and you open the tip of that marker and you let the meter sniff that, would you get an alarm with that Marks a Lot? What do you think? Yep, you're right, James. Now that's, like I said, that's what you'd see people doing in the old days. Now, when you're training people to use these they're typically 4-gas meters, you're going to tell them they have to do an official bump test per the method required by the manufacturer. But in your training, I mean, you could take something to set it off just to show that it works. That's probably not a bad idea, but that will not constitute your bump test. Okay, your supervisor. They're going to make sure that rescue is available. And let's just say that the response time is good enough from somebody off site normally, but they've got to be at the station. And if you don't have hazardous gas involved, you might be able to justify a longer response time. But again, these folks need to be available. And the entry supervisor is going to remove people that aren't supposed to be on site. And of course, your attendant's going to work with them to do that as well. And this is very important. You have to evaluate that your rescuer can remove that person from that space safely, and that they have the tools, methods, and equipment to do that. They can reach the victim within time frame that you've determined, and they're properly equipped, and they agree to notify you if their services become unavailable. But be careful with off-site rescue because response time is critical, and if the atmosphere is the likely hazard, I don't know that I would want to depend on that because of the response time. Okay, rescue team, they need to know the hazards they could encounter and to provide them access to permit areas so that they can develop plans. So you don't want to train somebody and not train them on the particular type of spaces that you have. Okay, rescue services employer who's designated for emergency rescue must be provided with all equipment, PPE, and they must be trained, and they must be proficient from their training. Now, let's say you've got somebody using SCBA, self-contained breathing apparatus, and they're going to do entry rescue with the SCBA. What else is required for that SCBA? SCBA. You have somebody using them for rescue. Training, testing, fit testing. So you got the whole respirator program right there. That they're going to have to be medically qualified, trained, fit tested. And so if you're using SCBAs or respirators, then there's a whole nother area of training. Now, with your rescue, you must have each affected employee with rescue, basic first aid, and CPR. And you must have at least one person that has that training, that certification. Now, let's go ahead and stop, and this is one of the most important slides, and this is also true for general industry. Let's say everybody's trained in confined space entry. You've got to do rescue training at least once every 12 months. That's annually. Okay? And if they're not training on all your different particular spaces, they must be trained on each type of confined space that they would be rescuing folks from, different types of rescue. So you may not have a frequency of training for your initial training until you get to rescue. And then next thing you know, you're dragging everybody in this situation because if you're training on rescue, you're involving your attendant, your entrant, and your rescue people, and your supervisor. So you're going to be training at least once every 12 months. So that's one of the most important things to remember today. You're going to try to do non-entry rescue unless the equipment won't work for that. So like I said, if you're using a winch and you can't winch them out, you have to have another form of rescue pre-planned. Retrieval systems, if you're using a winch, you're going to have a harness on the person, and you need to know when you're getting that person out that the way you're winching them out is not going to cause them to be trapped at the exit point. So the attachment point may be a little bit different, like this slide says. Okay, and your device there is talking about something like a winch. We're not going to use a pickup truck. We're not we're not going to get a bunch of people on a rope and everybody pull on the rope. It can't be anything like that. It has to be a professional rescue means. Okay, if your person's exposed to a chemical involving SDS, safety data sheet, you must have that available there. So if there are any chemicals involved in this work, you're going to have those right there available, in the work area. And of course, in an emergency situation, you're going to be referred to that information as well. Okay, so your employees need to be involved in this program, and communicated all the information needs to be communicated to all your employees that are affected. So now, today we've talked about the definition of confined space construction, which is similar to general industry. We've talked about the difference between a permit space and a non-permit space, and we talked about methods to determine hazards like air sampling. We've talked about lockout, tagout. We've talked about different responsibilities for different people, and we've talked about different types of rescues. Now, one thing I want to go ahead and cover here at the end is what are the big differences between general industry confined space and construction confined space? And you may have picked this up. In construction, you have to have coordinated activities between the multiple employers, like the subcontractors, the GC, and the host. In construction, you have to have a competent person to evaluate the work site and identify the confined spaces, including permit spaces. In construction, you need to require continuous atmospheric monitoring whenever possible. In industry, it says periodic monitoring. Now, I like continuous. That's what I would do. But construction standard says continuous monitoring is preferred. And in construction, it allows for the suspension of a permit rather than cancellation. So, at this point, we didn't stop much for questions, and this was a lot. We covered a lot today. Does anybody have any questions or comments at this time? Any questions or comments? Now, I will tell you that the presentation is available at nclabor.com. Under OSH presentations, you can click on confined space for construction. I also want to tell you that we have a general industry confined space training just for general industry. Hopefully in the next few months we'll have that one available. That's a little bit different, but very similar to what we've talked to today. So a lot of the concepts today apply to general industry as well. And I don't see any questions. So anyway, with that said, I've got 11:14 a.m. and I'm going to call that as the end of our webinar. And I want to thank you for being interactive today, answering questions. You've all been good. Hopefully you aren't too confused. If you know the general industry standard, then the construction standard is almost the same, except with just those few differences. So anyway, thank you for your time, and I've enjoyed having you today. So anyway, that's the end of the webinar. I'll stay on here for just a few minutes. You're welcome. Thank you. Thank you, Jonathan.
Gear up. Gear up for back to sport at Academy Sports and Outdoors during Texas's tax-free weekend, August 9th through August 11th. All gear, all weekend, all tax-free. And now through Saturday, save 25% on select Nike and Under Armour apparel and footwear. Get your student athletes ready for fall sports with the best brands at the best prices. So shop your nearest Academy store today or visit academy.com. Exclusions apply. See academy.com/tax-free for more information.
Okay. I've got about 11:16 and I don't have any other questions. So I'm going to go ahead and get ready to close the webinar. So I'm going to go ahead and get ready to close the webinar. Again, this is Tom Wilder with North Carolina Department of Labor. Thanks for being with us today. This is the end of our webinar. Again, look forward to hearing from some of you tomorrow because we have another webinar tomorrow on the silica standard for construction. All of you have a great day. Talk to you later. Bye-bye.